In this video, we'll develop a basic model for the contact force. Here I have a book that's sitting on a desk, and so I might say there is a contact force on the book by the desk. The contact is the type of force, the book is the object, and the desk is the agent. For a contact force, the object and the agent must be in physical contact with each other. For a contact force, there are no rules in the basic model. The magnitude can be anything, the direction can be anywhere, and you can use any type of notation. I have some force F with a magnitude F in some direction. For example, the force on the book, the contact force, might have a magnitude of 20 newtons and might point up. To explore that a little further, imagine someone is grabbing the book. This is supposed to be a hand. And so there might be a contact force by the hand on the book that is 30 newtons pointing down. But it doesn't have to be. It might have a magnitude of 45 newtons, pointing 45 degrees below the horizontal axis. Or it might have a magnitude of 50 newtons, the other one was to the right, down 30 degrees to the left, vertical, indicated by the yellow arrow. Or, in fact, the person may be lifting the book, exerting a force of 20 newtons up 50 degrees from the horizontal to the left. Just because you have this sort of picture of a contact force, the contact force could have any magnitude and in any direction. Later, we will develop a more sophisticated model that breaks it up into a friction force parallel to the surface and a force perpendicular surface. But for now, we'll just have a magnitude and a direction. Consider now a person holding a book aloft. We've established a coordinate system with a positive x up. Now we're told that the person is exerting a contact force on the book that has some magnitude F that is up, and the total force on the book is 0. Well, what are the forces on the book? Well, we know there's a contact force. It has a magnitude F, and given our coordinate system, it is in the positive x direction. But we also know that there's a force due to gravity on the book. And given our gravitational force model near the surface of the Earth, we know that it has a magnitude of mg, where m is the mass of the book, g is the acceleration due to gravity, and given our coordinate system, it is pointing in the negative x direction. Well, we're told that the sum of the forces is equal to 0, so if I add them together, they will equal 0. And using my notation for forces in one dimension, I have a contact force in the positive x direction, a gravitational force of magnitude mg in the negative x direction. The minus sign indicates the negative, and so I can just use arithmetic. F minus mg is equal to 0, or the magnitude of the contact force is equal to mg. So for the basic model of the contact force, the object and agent have to be in physical contact with each other, but that force could be of any magnitude in any direction.